is ready to start the
This call is
presentation.
now being recorded.
So let us start the session.
Good afternoon, everyone. We are honored to get our next speaker of the day, Dr. Swaphan Devarma. He is an assistant professor in Department of Computer Science and Engineering at National Institute of Technology, Agartala. He received his PhD in nanotechnology from NIT Agartala in 2016 and MTech in Computer Science and Engineering from Tripura University in 2010. Prior to that, he completed his bachelor's in the same department from Northeastern Regional Institute of Science and Technology, Arunachal Pradesh in 2000. Dr. Swaphan Devarma is an active researcher, teacher, and a mentor. His contribution in his research area have been admired by highly standard journals and conferences. He is currently involved in active projects, problems, and prospects of small-scale industries in ANI and Sun Open Source Laboratory as principal investigator. Sir, it will be an honor for us to listen to you, and we will also get to learn a lot from this session. I'd also like to add, it's an immense pleasure for us, the organizing committee, to have you all here. Over to you, sir.
पावर चला गया होगा पावर है तो please bear with me, I'm having some technical problem. Just a moment, please.
No issue, sir. You please take your time.
कहाँ नहीं हो रहा, फुल स्क्रीन कीजिए। हाँ इसमें लगा नहीं, हाँ ओके। Hello everyone, good afternoon. Hello.
Yes, sir. Audible, sir. You.
Yeah. Am I audible to all? Jayanta?
Sir, you are audible. You are audible, sir.
Okay. Is my slide visible in full screen?
No, sir. It is not in full screen.
Oh, it is not in full screen. Hold on.
Sir, and share your entire screen, then make it in full screen.
Okay, let me do it that way. हाँ. वीडियो बंद कर दीजिए. हाँ.
Yes, now it is in full screen, sir.
Okay. Do you see my video? I mean, am I in front of the camera?
Yes, 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 sir.
So I'm going to start my presentation. Okay. So sorry for the delay. Let me take video बंद कर दीजिए. Okay. Okay. So good afternoon to everyone. My slide is in full screen. I hope so. Jayanta, please confirm me.
Yes, sir. It is in full screen.
Very good. So sorry for the delay that because of technical problem going on in our institution. However, I am very delighted and very much grateful to the ATAL FDP program, and special thanks goes to Tripura University, Dr. Jayanta Pal, who has taken keen initiative to make this program success and going to be grand success. Anyway, let me not kill any more time because time has already been gone by around 20 minutes. So my discussions on the topic is quantum materials and specification. Actually, I will not go deep much into mathematical calculations or mathematical derivations. My main motive is many of our engineering background, they hardly do understand the meaning of quantum or quantum theory, or so to say classical physics and classical physics and quantum physics or quantum mechanics. So with this very beginning of our discussions, I shall go some very basic and preliminary discussions on the quantum related analogous terminology. After that, we will come to the materials. Actually, what does quantum means actually? It is actually an annexer of two words, quanta or quanto, sometimes we call it. Actually, quantum is a derived Latin word for an amount or how much. Meaning by from a chunk of bag of words, you can say, or a chunk of materials, how much of amount you want, the smallest unit of amount, how much you want, that is quantum. And in modern physics understanding, it is the smallest possible discrete unit of any physical property such as energy or matter. Quantum came into the later usage in 1900 when the physicist Max Planck used it in a presentation for the German Social Physical Society. So quantum is actually, has already been highlighted here. It is discrete unit. So many of us, those who are engineering background, discrete unit means it is not in a not in a analogous or not in a analog way. Like analog way means suppose a number 1 plus 2 divided by 2, the average becomes 1.5. Okay, so that is our that is not our discrete unit or discrete number. So as we have seen present days, that we have two views of time system. One is the watch, you can say. The one is the previous the previous one is our analog watch view dial, and presently we are having some fascinated or fancy watches. Those are discrete, that is in the digits view. So that kind of thing we can give a comparison view or comparison example. Now basically quantum, as we have discussed, it is the smallest unit or smallest quantity of radiant energy. Actually quantum is relevant to your energy, okay, which is equal to Planck's constant times frequency, that is h into frequency. Okay, so as we have already discussed that it is smallest unit or smallest quantity, so we always refer to those subatomic particles like electron, proton and neutron. So in sign conventional or in a subatomic level, we always use electron for discussion of quantum. प्रशांत, अरे फिर से अटक गए यार, स्लाइड जा नहीं रहा. Okay. So this slide, what is quantum or photon? Light quanta means called photons are the smallest discrete amounts of light. Suppose whenever we see luminance of light or a chunk of beams which strike to our eye, then we see which portion is what and which portion of the light is to be considered as one point of light. We cannot differentiate by our physical real world, but the light beams is also having numbers of photons or number of quanta, or you can say quanta light or light quanta. For light quanta, we use the formula, the energy of a photon, which is equal to Planck's constant and frequency, which we have just discussed now. So the way that we interpret is that the energy that's present in the electromagnetic waves is in these discrete packets called light quanta or photons. So sometimes quanta is also considered as a packet of lights. So for example, suppose if we define definition of a subatomic particle in classical physics, then if we consider this particular picture is an electron, then in our classical physics or in our real world, we can say, we can see, or we can presume, or we can visualize the electron in this view or in this format. But in case of quantum physics or quantum mechanics, we do not say so, or we do not visualize so, or we do not presume so. It will be something like this. So the definition for the quantum physics for subatomic particle like electron, photon, or which is in the range of nanometer or picometer, then their definition for the quantum physics or quantum mechanics will be in a wave form. As in the previous slide, we have seen in the classical physics, we can visualize or we can understand the presence or the circumference boundary of the electron is green, circumcised or surrounded by black area. We visualize it, although we cannot see electron by our naked eye, but in the level of nanometer or picometer, we can visualize with high camera or high with high experimental camera. It's not a wave or water or oblique sand, meaning by the electrons which we define in terms of quantum mechanics, it is actually in a wave form, which we have seen in the previous slide. Actually, it is not physically real. Why do I call it is not physically real? Because this wave form, if we consider the example of electron, the electron may be, we presume in the high electronic camera, which is which is capable of seeing very much level of nanometer or picometer, they can be seen as a solid marble like, but they cannot be seen in the form of wave. But why I do call it is not physically real? Because the electrons or the subatomic particles, when they are defined mathematically and seen their behavior, they may be sometimes found in wave function form, or maybe in this sometime it is in the form of classical physics form. So that is why they simply changes their forms, unlike water or sand. Like we see water waves or sand waves in our physical world, and they are real. But the wave function of the particles which they behave are not same as of that real world water wave or sand wave. Actually, it is an abstract mathematical wave which is giving us the presumption of the wave. Discussion about the wave function, we see, as we know what is wave. Wave has got a ripple shape, and it will have amplitudes, up amplitude, down amplitude, that is positive amplitude and negative amplitude. So when we multiply the highest amplitude square, the function, wave function, then we get the probability distribution in the down figure, in the down waveform. This probability distribution, why it is required? Because the high probability arrow marked here is the highest possibility to find position of the electron is maximum there. And next arrow, which is written with the arrow marked low probability, it is the lowest probability where position of the electron can be found. That is the interesting part of this wave function. In the real world, in the experimental way, in the electronics experiment or in the physics experiment, we always assume that electrons, they are not static in nature. That is okay. But still then, with respect to time, we can find electron somewhere in the x-axis or y-axis, or in 3D axis, that is z-axis. But in case of wave function, with respect to the high amplitude peak, the electron possibility is probable to be found. Meaning by high the amplitude of the wave is high the probable to find the position of the electron. High the minimum the low the amplitude of the wave, low the probability to find the electron. So this is the interesting part of our quantum physics or quantum mechanics, which differs from the classical physics. In quantum realm, the nature of the electron, or rather the findings of the electron in its position is in wave form in quantum realm. And in our real world, we had always been accepting the electron in the dot way, a black dot centered with green color. So quantum realm and our real world, it differs. But why do we are interested in quantum calculation or quantum measurement? Because the quantum measurement gives us some measurement which is useful to us. Had there been no quantum theory or no quantum fundamentals, then it could have not been possible for our real world to exist. Because with our only classical physics, which Sir Isaac Newton has derived out the three fundamental formula, which is very popular, that is force is equal to ma, mass into acceleration. With that theory only, the real world cannot proceed or cannot furthermore advance. That is why quantum realm or quantum measurement is very much important to us. So in between we have measurement barrier. In between quantum realm and quantum world, real world, we have measurement barriers. And one interesting thing is the wave function or the wave. The wave, when it propagates, they collapse one another. I will come to that point. They collapse one another. That means what? If one wave superimposes the other wave, meaning by if one wave mix up with another wave, it is called superposition. That is also interesting point that I will come to the next slide, in the coming slide. This previous slide we are going to see in our theoretical perspective point of view, the quantum realm and our world or real world. This is what we call it as particle wave duality. What it says, a particle wave duality means a particle can act a small solid dot or a wave. That means what? Like a person having two personalities, something like that. Okay, in many of the present movies and all, we see a person having dual characters. Sometimes he acts as a good person. Sometimes he acts as a very arrogant, very furious person, something like that. So this quantum mechanics and classical physics also acts the same thing. So what it says in Broadway, it is the concept in quantum mechanics that every particles or quantum entity, every particles means I'm referring here electrons, protons, those subatomic particles. Even it works in case of compounds also, in atoms also. So let me repeat it once again. It is the concept in quantum mechanics that every particles or quantum entity may be described as either a particle or a wave. Sometimes it acts as a particle, sometimes it acts as a wave. So it described as either a particle or a wave. कभी particle हो जाता है, कभी wave हो जाता है, ठीक नहीं रहता है. So both the way we have to consider it. That is the postulate, that is the fundamental principle of particle wave duality. It also expresses the inability of the classical concepts, because in classical concepts we see it is particle, not wave. But with respect to our quantum mechanics, it is wave. To fully describe the behavior of quantum scale quantum objects. That is why the particle wave duality acts like this. Because in the left orange side we see one wave. Whether the particle should be considered like wave, or in our real world, whether it should be considered like this dot. So what does it actually look like? Whether it is wave or it is a solid dot. So this makes us two types of definitions. One with respect to quantum mechanics, one with respect to classical physics, or yes, classical physics. So both definitions are correct with their respective point of view. But when you consider quantum mechanics and classical mechanics, then both the definitions you have to consider. Otherwise, the meaning of quantum realm will be fail. That is why Albert Einstein wrote or stated that it seems as though we must use sometimes the one theory and sometimes the other. What he is saying here is that we must use sometimes the one theory, that is, he is referring to classical physics, and sometimes the other. The other means the quantum mechanics or quantum physics. While at times we may use either, meaning by while using them we may use both. We are faced with a new kind of difficulty. What he is meaning over here, new difficulty means, because for defining, for using a particular particle, we have to consider two kind of definitions. What he is referring to have a new kind of difficulty. We have two contradictory pictures of reality. What is that? Separately, neither of them fully explains the phenomena of light, but together they do. Meaning by, if you define them separately, taking the example of light, then they are not perfect, they are not complete definition. But if you consider both of them, then the definition is complete. That is why he referred, or he wrote this difficulty of his theoretical mind. So these experiments are very known and very popular for defining the wave function, the double slit experiment. Suppose two narrow slits are there and a gun is there. When you fire through these narrow slits, then it touches to the background screen. Okay, sometimes we call it as interference screen also. And the strips of green color in the background, we see two strips which is through parallel to our two slits. That is why it could touch the screen through the fired gun in normal gun. But when we see the same example, same experiment, firing by electron gun or electron gun through the small slit, then we see interference pattern. Because in previous slide you see, through the small slits, the slits directly parallel to the slits directly pointing or parallel to the background, it is only getting fired there. Only two strips are seen. But in case of electron gun, interference pattern occurs. So what does it mean? Actually, what this experiment do actually? What does experiment make us realize? We see this through the electron gun, we fire the electrons. So different waves are formed because according to quantum mechanics or quantum physics, the particles energy or the particles, they are in the form of wave. So this wave when go through two slits, then these two slits again they collapse, they mix, they collapse, and they go and touch the interference screen. So this is how the formation of the interference occurs. The slits through which the wave of the fired electron gun or fired electrons, they propagate and touches the screen, then the highest direction fired by the electron gun will have the highest amplitude of the wave, where the probable finding of the electron is maximum in the first picture, which we call it as probability distribution. Because probability distribution is only occurs when the highest amplitude is squared, then probability distribution is done. So our interest is to find the position of the electron, where electron can be found with respect to our quantum mechanics. So the highest amplitude in the first image is the position where electron can be found or electron can be positioned. In the next one, in the next figure, the arrow mark in the right hand side is the lowest probable or lowest possible to find the electron position, because the amplitude of the wave is very low here. Okay, same thing in the previous picture, it is the same thing. So the maximum stripe that has been fired in the interference interference screen or in the screen, the maximum highest wavelength or wavelength, the amplitude is high there. That is the probable to find the position of the electron. This probable is something like mind game like. Previously we have understood that the slits through which the electron propagates, they again collapse and they again propagates and towards this touches the second screen. Very fine. But in this case, how does the wave function collapse? How does the wave function collapse? Meaning by the wave function when it traverses through the slits, again second waves generates simultaneously after propagating through the slits. Both wave propagates towards the next touch of the screen, and they are again, you can say, they are again superimposed in the sense that through the top view we can see superimposed, but if you see the horizontal way, they are not superimposed. So this propagation, this phenomena is not known to everyone. Nobody knows it. But I have used here one electron there, where electron can be found with respect to our classical definition. But with respect to quantum definition, it is not possible to define it. So that is why this wave function collapse is very much important. Now different types of wave function, different type of wave we can see. I'm talking about it, I'm referring to electron wave or a small particle wave. There are 4 numbers of wave figures here, or yes, and first one is a normal one, second one is a little bit amplitudes are very um, short one, then the third one is having a highest amplitude followed by both side small ripple, and the bottom we have 2 waves which is of the same size. So these kind of waves may occur or may exist during the wave propagation. Now, as our discussion was on wave function, so the wave function topic was interested for us, or it is important for us just to locate the position of the electron. So previously also we have discussed that to find the position of the electron, having highest amplitude will be the highest probable to find the position of the electron, which I have marked here with 2 black arrow, and the bottom one is a flat wave where the probability to find the position of the electron is very less chances. Actually, wave function can be superposition using summation of waves. We have seen summation of waves means one wave plus another wave, which is equal to the superposition of wave. So this can be understood in the later talk. Now we'll discuss entanglement. Suppose there are 2 waves, 2 wave function. One is bluish like, the other one is red. In the left we have bluish one, in the right we have the red one. Now think about 2 waves are coming, approaching one another in the opposite direction in the same axis. Say take it as x-axis. So they are approaching one another in the middle one, and now they are superimposed, meaning by both are mixed up. Now after mixing up, they are getting diverted one another in the opposite direction. One is in the right side, the other one is in the left side. Because you see, I have differentiated these 2 waves, one with green one, the other one with red one, when they were not superimposed, or when they are not mixed up rather. Once they mix up, I made them pink color. After pink color means now they are mixed up or superimposed. Now they're getting away from one another. So interesting thing over here is that now 2 electrons wave interfere and mix up, and they are getting away one another. So mathematically they are now one wave. As we have seen in the previous this one, I have defined that superposition of the 2 wave can be equal to one wave. That is the definition of superposition. So that is why I have mentioned here mathematically they are now one wave. What it does say so, it describes both electrons are inextricably linked. Inextricably linked means meaning by now they are linked. The either of the wave, if you take their measurement, you can get the information of the another wave which has been part away. So in this discussion, we can see it describes both electrons are inextricably linked if it is part billions mile distance. If one wave is here, the other wave is in another galaxy also, they can be linked. That is why Einstein was not happy due to this. As because if measured particles, that is one of the electrons here, instantaneously know where the other will be. And it is very fast, faster than light. So one question may arise from you that if it is faster than light, if it is faster than electricity, then why don't we use it for communication purpose? We cannot use it communication purpose because their results are random. You cannot get a true result all the time with respect to time. So approximity is high and probability is high, but exact discussion is getting result is very low chances. That is why it cannot be used for communication purpose. So suppose the left one is in universe 1, the right one is in universe 2. If we know the measurement of the, if we know the little information of the left one wave arrowed up, then we may have the measure of another particle which is in another galaxy, which is arrowed down. So this kind of fundamental is called non-locality. Non-locality means it is not local. It is in the universe, entire universe, this kind of phenomena is going on. Now, another interesting discussion is quantum tunneling. Quantum tunneling. Quantum tunneling is what? In classical physics, if we throw a ball against a wall, the ball bounces off the wall. How harder you throw the rubber ball, it will bounce back because it has got a high steep wall as a barrier. But in discussion of the quantum physics, what it says, if a wave traverses or propagates towards the barrier, if the barrier is wider or hard or steep and wide enough, then around huge portion of the wave will bounce off the wall, but few small portion of the wave will traverse through or penetrate through the barrier. Why? Because in quantum definition of tunneling, what it says, if the barrier is being made as small barrier, then the propagation of the wave, or the energy of the electron, which is in the form of wave, if we give maximum potential energy, maximum kinetic energy to it, then due to the conservation of the kinetic energy, the wave function or the wave energy will pass through the barrier. That is the fundamental of quantum physics, which fails in the case of classical physics. Okay. Same thing, if we realize this ball with respect to classical physics, the ball should not come up from the left to right. But if it is in the definition of quantum physics, then portion of the ball will come and cross through the barrier. Okay. So we were very much in discussion with the wave function or wave. Actually, wave function equation is given by Erwin Schrodinger equation, which is h cap xi equal to E xi. H cap means Hamiltonian operator, and that one is wave function, and E is the energy. Actually, in our simple classical mechanics, what we see, total energy is nothing but E equal to potential energy plus kinetic energy. That is the fundamental definition we have come up with, the definition from the Newton's law, isn't it? But in Schrodinger, he says something different. The Schrodinger equation plays the role of Newton's law. Okay, fine. He follows the same thing as of Sir Isaac Newton. And conservation of energy is classical mechanics. That is, it is the important here. It predicts, it assumes, it prejudices to you that the future behavior of a dynamic system means like motion, rotation of a ball, rolling of wheel, spinning of our earth, revolving of our earth around the sun, heavenly bodies, those are all dynamic system. So it predicts. Why this quantum mechanics is important? Because it can predict, it can give you idea, it can give you some small portion of good result, that in future the dynamic system how it will act. It is a wave equation in terms of the wave function, which predicts analytically and precisely the probability of events or outcome. For example, suppose behind me there are two persons standing. When I see them, they are standing behind me. One is little bit nearer to me, the other one is little bit farther to me. One example, please consider it. And a person in front of me, he is trying to kill that two person. One is near to me, the other one is little bit further to me, but they are standing back of me, in my backside. I turn my face, I see them, then I turn back, and I see in front of me a person holding a gun and try to fire them. When I close my eyes, when I heard two firing, then I would think that, oh, that standing two person will be shot and they are died and they are fallen down on the ground. This is one probability. Another probability is what? The person who is holding the gun, he fired two bullets. One hit the person who is near to me. The farthest one is missed. That means what? The farthest one is still standing, and the nearer to me, he has fallen down. This is another probability. The third probability is just this vice versa, that the person who is standing to me, near to me, he is not hit by the bullet, but the farthest one is hit by the bullet, and the farthest man is down, fallen on the ground, and the nearer to me who is standing behind me, he is still standing. That is also another problem. The other problem may be the person who has hit the gun with the two bullets, he might have missed the person who is standing behind me. One is standing behind me, which is nearer to me. The other one is in the little bit further to me. He might have missed it. So when I close my eyes, I can predict four options. That is the interesting thing in the Schrodinger's equation or the study of quantum physics. So probability of outcome of the events are being found for the future behavior for a dynamic system. Okay. The last line, let me go through it. The detailed outcome is not strictly determined as I have seen. When I close my eyes, two persons standing behind me, are they completely the same thing? What same thing even occurred? What I am thinking? That is the thing. It is being detailed here. The detailed outcome is not strictly determined. It is not completely 100%. There might be 4 possibilities where the example that I have taken. But given a large number of events, if there are events many times, repeated many times, the Schrodinger equation will predict the distribution of results. Very good. When I was given 4 number of options for 4 times, 2 persons, they are laid down, 1 person laid down. Let me speak in this way. In the first probability, 2 persons, they are killed, lying on the ground. Second probability is the farthest person, he stands, but the near person, he is killed and lied on the ground. Third probability is the farthest person killed on the ground and the nearer one is not killed and still standing behind me. The fourth one is both of them are standing behind me. This is the fourth probability that given to me. Had there been 8 numbers of 10 numbers of events number given to me, then at least one probable outcome will come to me. So that is the Schrodinger's equation will predict the distribution of the results. Okay. Now, as I have not gone through any mathematical equations or mathematical derivations, however, because I want to give you all theoretical perspectives. As we know, our total energy is our kinetic energy plus potential energy. We are known from the school time. According to classical conservation of energy, we see energy is equal to half mv square, that is kinetic energy, and potential energy is half kx square. K is the position, which is harmonic oscillator example that we know it in the school lifetime. Again, Newton has come up another formula, that is force is equal to ma, that is also energy. Force means force is also energy. Ma, mass into acceleration, equal to minus kx. Okay. Now interesting part is if we go to mathematical derivation, then quantum conservation of energy is p square by 2m plus half kx square, which is nothing but your Hamiltonian operator, even in H, capital letter H. Okay. When we go for Schrodinger's equation, when we go to our Schrodinger's equation, then we derive it in such a way that in making the transition to a wave equation, because the force need to be transformed to, the physical force need to be transformed to wave equation, which is given by again PQ type P, which is derived from h bar by I delta x, and the Hamiltonian operator is given rise by physical variables that takes the form of operators, which is nothing but out here the kinetic energy will be given to Hamiltonian equation with the wave function. So in short, we can say h wave function equal to energy wave function. Okay, this will be clarified again in the next slide. Let us see. You see here, this is also look like a little bit complicated, but as the derivations is given by some notations, so this gives you this delta square is nothing but del r square derivative del r square by derivative del x square plus del r square by derivative del y square plus del r square by derivative del z square. It means what? This delta square is nothing but for a Cartesian coordinates. There are three coordinates, x, y, z coordinates. Because in space there is no such coordinates. There are multiple coordinates, multiple axes. Then delta square will be behaving these three coordinates in Laplacian Cartesian coordinates. Psi is the wave function. Of course, B is the potential energy, and h bar is the Planck's constant divided by 2 pi. That is, h divided by 2 pi is h bar, and m is here obviously your mass. This will be again surely again processed and will be easy understood by this slide C. Minus h bar square by 2m delta square wave function plus potential wave function equal to ith delta wave function divided by dt. dt is your time. So as I have discussed there, that h bar square is nothing but it is Planck's constant, which is nothing but h divided by 2 pi whole square. 2m means the mass of the particle being described. So particle may be electron, the particle may be in the space, those electrons, because as we have discussed in the case of our entanglement, that if two wave approaches in a same direction and being repelled, let me clear you in this way. If two in entanglement, it's not in entanglement. If two repulsive particles repels one another, then there rises their energy more explicit way. I repeat, more explicit way, and give rise to another form of energy. Same thing happens in our sun also, in stars also. Suppose two protons, they repels one another, give rise to 4 heliums or something. Okay, then from them enormous light wave energy is produced, which we see or we feel it from our Earth or from other heavenly bodies or some other planets, our solar system planets. So this delta square is the factor here which gives you the quantity describes how the wave function changes from one place to another. This delta square, the delta square which you have seen in the del r square of by x square, del I x square, this is the main function, how the wave function will change, in which direction and in which axis. So it is one kind of operator by which your wave function will change in every instantaneous of time or with respect to your time. Plus B wave function, which describes the force acting on the particle. Obviously, suppose a particle is pushed very little, then it will accelerate very small. Suppose a particle is pushed with high potential energy, then it will go with a high kinetic energy, obviously. Sorry, excuse me. So V wave function is very simple here. That is in the classical discussions we see. Suppose a marble is transversing on a x-axis. If we roll them with a small energy, then it will, from potential energy to, it will convert to kinetic energy, and it will go slowly. But if you hit very hard to the marble, then the potential energy will be having a high impact converting to kinetic energy, and it will go fast, like we see when we play carom board, isn't it? Harder the striker you hit, harder the coins, it strikes out the four boundaries of the carom board. But in case of wave, it works like that. But who makes them? Out here we had talked about potential energy converted to kinetic energy. But in this case, it is a little bit different. Which operates or which decides the wave to be how and which form, which is being operated by your delta square. If it is in the case of space, then it will act a different form. If it is in the case of a very small particle like electron, proton, neutron, then it will be different. So this wave will be having completely dependent on your time dependent, or sometimes we call it as frequency. That is why it is equal to ith delta wave function derivative of delta time. Ith means it is an imaginary number. Ith, you know, it is the square root of -1, which is imaginary number, because we don't have all the time integer number. We cannot have, because if we have integer number means it is concrete, having a 100% result in one peak or second peak or third probability. But in case of mathematical quantity, the ith means it is an imaginary number by which let you predict that after how many probable the one probable result may come out in the event. So as we have seen that in the previous discussion, energy is nothing but frequency times your Planck's constant. That is why wave function is also time dependent, or wave function is also multiply of frequency. Okay, so the ith delta xi by delta t is nothing but it changes the shape with time. Okay, next slide is again given a little bit sign. Many of us may not know why this negative sign is given in front of the Schrodinger's equation, because in pond, you must in pond we sometimes used to throw stone in a steel pond, then wave occurs. Then if you throw another stone, a little bit bigger stone, then with high potential, then it will convert to kinetic energy. Then the small waves are being cancelled by the big waves, or vice versa. Small waves are cancelled with the big waves. That is why for cancellation sign we give this negative sign. You see, a wave function with negative sign works just like any other wave with negative sign. For example, water waves with negative height cancel out with waves of positive height, and vice versa it is. You can also make a negative wave on a string by pulling the end down and back up, which will cancel with a positive wave. Okay, so these all were discussions about our quantum mechanics, because these are scratched, sometimes we forget it. That is why I would like to give you this quantum material specification. Actually, sometimes we think that specification means some ratings of materials or something like that. It's not like that. Actually, it is a talk about the assumptions that we are comparing with the classical physics and quantum mechanics. That is why the topic is quantum material specification. Okay, so let me go to some small discussion on quantum confinement. Actually, confinement means what? There are two different words. One is quarantine, the other one is confinement. A person is quarantined means he is bound to stay in a place for a period. For a period. So during Corona time, many of us might have been in quarantine for a days of 14 or for a days of 20. After that, if negative is found in the antigen kit or in then we are released after 14 days or after 20 days if you are found negative. But in confinement is something different. Confinement means you are permanently tied up. You are permanently tied up. Why I have taken this bulk materials? Because in a bulk materials, electrons are free to move. Electrons are free to move. So as electrons are not static in nature, they are dynamic in nature. They cannot be found anytime. Like a person who is like a YouTube blogger, like those who move, those who tour state to state, country to country. Likewise, electron is also like that in nature. It never remains at home. When it will be found, where it will be found, at what time it will be found, no one can predict. So confinement of the particle is very much essential in our electronics life, because electron is the only particle, by making him work in our electronics or electrical devices, we are getting the maximum favored result or the maximum comfort result. Let me discuss in different way. Suppose in our real world we have got 3 dimensions or 3 axes. One is x-axis, the other one is y-axis, the third one or the last one is z-axis. When we talk about length and breadth, we get a plane. Okay? If semiconductors, I hope you understand semiconductors, obviously you might be. If semiconductors, when they are doped, when they are mixed with another semiconductor, then the experimentalist or the researcher, they found that their conductivity of energy in form of electricity is very high, acquiring less amount of space, consuming less amount of energy. I repeat, doping is a process in which pure semiconductor and impure semiconductor, they are mixed. Pure means intrinsic, impure means extrinsic. So when intrinsic semiconductor and extrinsic semiconductor, they are mixed, it is called doping. Many of the semiconductor, when they are made compound or highly doped, their energy behavior has been seen that when they were in a pure nature available, energizing them with electricity, their energy behavior is found very normal. But when doping is done and they are energized, their electrical outcome behavior found to be very high, exponential. And beside that, their energy consumption is also very less, and space occupied is also very less. So the researchers, they have been still working day and night let them be working very good for us, faster for us, and let us do for more doping with different types of semiconductor. That is why this cell phone, mobile phone, electronic gadgets, present days, many devices have been come out in the market because of the doping of the semiconductors. And the hero of the this one semiconductor, sorry, the carrying of energy or the spark spike of the energy is done by the hero electron. That is why we need to make electron in work, so that we should find our life very comfort with respect to design, with respect to making of more good devices. That is why we need to fix them in a position, as in when we get chance to grab the electron, it should be available. So that concept is called confinement or confined. So when it is x and y given to give free electron movement, and the z axis is confined, that means the z axis is given confined, then electron cannot move there. So it is freely available to move x and y axis only. So this arrangement of semiconductor doping is called quantum well, or sometimes we call it as quantum plane also. So thereby only x axis and y axis is the allowed path or allowed area where electron can freely move. Okay, the next one is quantum wire. In this case, the movement of the electron is confined, not quarantined. It's confined in the axis of z and in the axis of y. So only it can have a movement in x axis, that is in a line type, in a straight line type. So it is defined as quantum wire. Oh, I lost another slide. The other one, the last one is your quantum dot. Quantum dot is what? The electron free movement is not allowed to move nor in x-axis, neither in y-axis, and even not in z-axis. So it is let remain in a jail-like. When a person does any criminal activity, then he is put in a jail. So in this case, the electron is also kept in a jail. So that one is called quantum dot. All right. Okay, so I think I end up my discussions. Hello, Jayanto. Hello. Hello, Jayanto. Hello. Hello, Jayanto.
Yes, sir.
I think I have completed my discussions.
Okay, sir. So may I ask some participant for any queries if they have? Yeah,
So
from the
one thing I
participation.
want to,
Yeah.
okay, one thing I want to ask is that like you told us about the negative value. So practically, if we talk about the energy, let's say there is no thing like negative energy, or if we'll talk about the frequency, so there is nothing like negative frequency. So how like you displayed one slide where you have written the word negative. So what is the significance of this negative, let's say, energy or the negative frequency, and how quantum computing is dealing with those values as well?
Hello. Yes, actually, in Schrodinger's equation, putting negative value, it doesn't mean that it is having negative energy or negative impact onto the equation or in the quantum measurement. Putting negative means what? When you when energy is in the form of wave, when they propagate and mix up, as I have discussed, and when they are mix up, then their propagation towards the another obstacle, during that time the the lowest the how to explain you, the highest amplitude, whether it is up or down wave,
Hmm.
it will cancel the positive wave. That is why the Schrodinger equation is given negative value. It is not having any kind of um, having parameter on analogous to negative energy or calculation in the quantum computing.
Okay.
Thank you. Any further queries from any other participants? Please share. Okay, sir, I hope there is no queries. Again, if I mean you feel to ask anything to the expert, then you may drop your queries. We will
Yeah, I
forward
will.
to the speaker.
Yeah. You can mail me through Dr. Joyantopal. You may reach me. He will forward your queries, and I will give you in written format. Okay. Thank you so much.
Okay, sir.
Thank you, everyone. Thank you,
Sir,
Joyanta. Yeah.
yes, sir, I would like to thank you on behalf of the organizing committee and Tripura University as well for your valuable time and this expertise talk. Thank you very much, sir.
Thank you. Thank you all. Thank you.